to you, all of you. My name is Ankur Mehrotra, and I'm Managing Director of Meteonic. I thank all of you to join this interesting webinar. Before we start, let me introduce you Meteonic. Meteonic Innovation is a leading software solution company which is serving 150 plus customers across India and abroad for the last 14 years. We provide automation and integration solutions to simplify your complex development software to help you to write quality and secure code. And let me introduce today's esteemed speaker, Shiri Karad. She is the Director of Product Management at WhiteSource. She has extensive technical knowledge, savvy in cybersecurity with passion for complex systems, constantly working with global customers across Europe, Latin America, and Asia Pacific. She is a known speaker at tech conferences, conducts various workshops and webinars on cloud computing, DevOps, and application security. We will take questions. Please list them in chat box, and Shri will answer them at last or in between. So without any delay, let me give stage to Shri. Shri, over to you.
Thank you, Ankur, for the intro. So today, really, we're going to discuss software composition analysis. And this is really a big deal. I mean, this is a major part of your security application portfolio. So without further ado, let's just jump into the slides. One of the most important things is to understand that open source hasn't always been there. Right? Open source is one of the biggest revolutions of the last 10 years, more or less, in the software world. And if we're talking about 10 years ago, only 5 to 10% of the actual code was open source code. The other part was proprietary code, right? That the in-house developers would write. And today, 60 to 80, sometimes even 90% of application source code is based to see arise in security issues in open source, and more vulnerabilities are being disclosed. So it's, even though you're using open source, which is just out there and public, it's still up to you to ensure that your product is secure, meaning, first of all, it doesn't contain any vulnerabilities. And in this webinar, I will provide you the tools and the action items that you guys have to take in order to make sure that your application is secure, it doesn't have any vulnerability. And the second aspect of that is, does this open source component comply with my organizational policies? We have a very big issue, which is licensing. So even though open source is out there and it's public and everyone can use it, sometimes there are problematic licenses that do not allow you, let's say, to change the source code, or they don't allow you to distribute it and sell it. So again, this is a very important issue that we all have to be aware of. But the thing is that it's not that easy. I mean, the problem is that verifying that each and every component is secure and complies with your organizational policies has become really increasingly complex. So it keeps becoming more and more problematic to actually verify each and every component, right? For a medium-sized company, you have like thousands of open source components, maybe even more just in one application. So think about what it is to actually verify and go one by one on each component. So, and it's not the only thing. The second thing is that information about open source components is scattered across hundreds of sources. It doesn't have one source where you can find all vulnerabilities. And these sources have different levels of credibility, right? Not all sources are really true and have all the vulnerabilities. And also, most databases are not very easily searchable. So if you are a medium-sized or a large organization, you probably need an external tool to help you deal with that. And you always have the option of not managing it, right? Not managing everything, and this will basically leave you exposed. On the left-hand side, we can see that we have more and more vulnerabilities to track, right? So I said about this open source revolution. We can see that with the rise of open source, we have more and more components in GitHub, let's say, or other repositories. We also have more and more vulnerabilities that are being exposed. So here on the left-hand side, you can see the number of new open source software vulnerabilities found per year. And I can also already say that for 2020, we started gathering the data, and it's almost 2 times larger than 2019. So this is really becoming a very problematic thing, and you cannot ignore it anymore. The second graph that we see on the right-hand side is that there is less time to fix, right? You can see the attacks exploding 0 days. 0-day vulnerabilities are vulnerabilities that are not exposed, right? They only a certain number of people know about them, and they are not publicly known. So we see these vulnerabilities before and after the disclosure. So what is really the disclosure? Disclosure is the publicity, right? The moment where the vulnerability is actually being published online. And from that moment where the vulnerability is published, we can see that the graph is increasing to almost 100,000 attacks. So this is really a big deal, and this is just a matter of days, right? It's not even a matter of weeks or anything like that. And we can see for specific CVEs here, we have more and more, we have less and less time to basically solve the vulnerability. So the good news are that with the publicity of the open source vulnerability, in the moment that the open source vulnerability is actually published, in most time, like 95% of the time, it's actually published with the fix itself. So if you upgrade and patch to the latest version of the open source component, you have a lot less chances to be exploited, and we will discuss it soon in the next few slides. So we really see that customers, I get to see customers almost every day that really manage open source poorly. I mean, they do want to manage the open source vulnerabilities, but they don't really have the right tools to do it or the right knowledge. And we see that this is really taking a lot of developers' time and productivity. So we see a lot of developers' time is being wasted on researching, trying to find their remediation, trying to find the latest version. And they actually spend most of the time researching and understanding what should be the fix rather than actually fixing. And if they had the right tools and they had the right knowledge, we would save like around 12 or 11 hours a week per development team. And this is based on the report that WhiteSource actually issued around 2 years ago. And I can tell you that the numbers are almost the same now. So it's both the right tools, but it's also really the knowledge. And in recent years, as mentioned, we've seen a very big spike. So hackers know that they have a shorter window of time to attack, and they try to exploit known vulnerabilities faster and faster. So really time here is a very important issue. And if we see developers investing like, 10 hours in just researching, really a waste of time, both expensive because developers are expensive and their time is expensive. They could have used this time to develop new features, but also because we are sort of running against the clock here. We want to make sure that we're not exploited in the small window that we have to actually patch and fix the vulnerability. So we do have a shorter time to react. And the question that we have here is how really can we gain the control that we need over the open source usage? And I think it's really down to, it's not very, very complex. We really have to do 4 essential things that will help us to make sure that we track open source vulnerabilities in an effective way. So the first one is really the vulnerability detection. This is the one that I want to touch first because this is the most basic one. Vulnerability detection. So you must be able to discover open source components with known vulnerabilities as early as possible, and we just understood why. This is actually when the remediation is easiest. So once a vulnerability is publicly disclosed, you are in a race against hackers to actually fix the vulnerability. If you don't know that you're using a vulnerable open source component, you can't win the race. This is quite obvious. So what we want to do is we want to make sure that we really reference the vulnerabilities and we reference the open source. We sort of know exactly which open source vulnerabilities we have. But the second thing is that we also do the right prioritization, which I will touch in a second. The next thing, after we have the vulnerabilities detected, right, we know what vulnerabilities we have. The next step after that is to remediate the vulnerabilities, which may sound easy, right? I just have to patch and make sure that I'm in the latest version of each open source component, but it's actually not that easy, as you can understand. In order to mitigate open source risks, it's really essential to remediate open source vulnerabilities as soon as they are discovered. But in most cases, it's really impractical to actually fix all the vulnerabilities. So it's not that easy. It's really important to prioritize the vulnerabilities, understand which ones represent a real risk and which ones are maybe not that risky. And then we need to provide development and the IT or the DevOps teams with the needed information in order to quickly fix the most critical vulnerabilities first. So how do we do that? What we need to do is to actually trace the analysis, right? We need to make sure that we are, if we can, we want to be on the latest version of the open source component. This is sometimes doable, sometimes it's less doable. You need to have automated tests in place in order to make sure that you're actually tracking all the vulnerabilities and that you can always patch to the latest version. So we'll touch more on that soon. The third thing I want to touch is inventory management. And it's actually crucial to understand what is your inventory or which open source are you using in your software. And to fully manage the open source security, but also the licensing and the compliance issues, we really must gain visibility into open source code usage across all stages in the software lifecycle, right? It's not just doing it as part of the coding or as part of releasing the software. It really needs to be something iterative that we keep on doing as we go. So the development, the deployment, like the ICD, and the production stages. And the last point is really open source license compliance. We already touched it, that you must establish an open source usage policy and sort of block inappropriate licenses that you don't want to have in your organization. Maybe it's because you distribute the software to third-party users, or you sell your software and the license that the open source component is using is not compliant with that specific usage that you're doing with the component. So it's really very important to conduct this due diligence that we do in order to have the complete visibility and sort of track the open source usage. And then now I want to touch the actual tools, right? So we have basically two types of SCA tools. And what I would recommend to do, and the best practice would do, is to combine both types in order to provide the right solution. So how do we do that? First of all, we have the governance solution. Governance is more for security teams, for the CISO, for the DevOps team leader, for the development team leader to actually know what the policy is. This is where they conduct their own internal research, and they understand this needs to be the organizational policy. For some organization, it will be, for example, no high vulnerabilities are allowed in the system. For some organizations, it may be only critical vulnerabilities are not allowed within the system. In terms of licensing, maybe a specific type of license like GPL is not allowed. Maybe it's not allowed only for part of your product that you distribute, and for the ones that are for internal use, you can actually use that license. So it's really a matter of, it's up to the security team or the legal team to actually set the scene for the compliance and vulnerability. So sort of the governance part, the policy, which policy does my organization have? The second type of tools is more towards the development. So the developers are actually the ones who maybe they are not in charge of security in the organizations, but they actually the ones who will have the detection part and also the remediation part of vulnerability. So we need to make sure that the development organization is on our side. They know what vulnerabilities are. They know that they need to remediate them as fast as they can. But also, not only they have this awareness, but also they have the right tools to do it. And now we will touch on some of the tools or more of the actionable information that you need in the different stages. So really this DevOps loop is something that we probably all know, at least the ones of you who have DevOps in their organizations. And what we can see is that it goes from planning to coding to building, then testing and releasing. And then basically we deploy and monitor and operate everything. So let's start with the very left of the life cycle. The left of the life cycle is really the planning. This is the moment where me as a developer, what I need to do is I have a task. Let's say I need to develop a specific feature. And now I go to GitHub or to Maven Central or to any repository, and I look for the right open source tool to do it. When I do this, when I do my research, what developers are usually looking for is something that is easy to integrate with their existing system, maybe something that is written in a language that they know, like maybe I'm a Python developer, so I will take something that's written in Python, so it will be easier for me to operate it. And we also look at the functional, right? Does it do what I need it to do, and is it easy to understand? So we have two more important things that today almost no developers are looking at. And this is really the security aspect. How secure is this component? How well is it maintained? Do they release bug fixes? How many forks does it have? How many downloads does this open source have? So these things actually make me more confident in this open source component that it should be part of my own code. The second thing is, of course, the compliance. So what WhiteSource has in this aspect is actually a browser integration. So it's a simple Chrome extension that detects the open source components in the web page. So let's say I'm currently in GitHub. I actually have a small browser extension that I can click, and it basically tells me what security vulnerabilities does it have, what are the licenses that it has, and whether or not this component complies with my organizational policy. And remember that this is the very beginning of the life cycle, right? This is the moment where it's sort of the cheapest to fix the vulnerability. It's not even to fix, it's to take a secure component from the first place so that I don't have to actually fix anything later. The second part is the coding part. So me as a developer, I took my component, the open source component, whether if I use that browser extension or I didn't. Now I'm actually coding, right? The coding is done in an IDE like VS Code, Eclipse, whatever tool that you're using. So the IDE integration for WhiteSource actually lets the developer see as they code, as they actually write the code, they have a file called package, like a manifest file, package.json or pom.xml. And this is where they can see all the different component, open source components that they are taking. And this is also where WhiteSource would highlight the vulnerabilities. And basically, as you code, you can see the vulnerabilities and basically fix them as you already write the code. So once you finish writing the code, there shouldn't be any vulnerabilities. And this is really a best practice because this is the moment where the developer is most focused, right? This is the moment where he invests time in writing the code. It's not after effects, maybe 1 month, 2 months after he wrote the code and he needs to go back to it. So really our goal is to have, the most efficient tools that we can have. Also, an important thing to mention, both in the browser integration and in the IDE, and also in the repo integration that I'm going to touch soon, the focus is really on actionable information, right? We don't want to give the developers, the entire research and what this open source component is and what the vulnerability is all about. It doesn't really interest them. The only thing that is interesting for them is you have a vulnerability, you have a fix, this is the version that you need to upgrade to, these are the steps that you need to take. We're not going to give them all the information about the vulnerability, whether it's XSS or whether it's, Bitcoin mining. It really doesn't matter. So all this research time that we spoke about before is really being eliminated. We don't need that. The next point is the repo integration. So whether your developers are using GitHub, Bitbucket, GitLab, or basically any other repository to store the code, they can use the repository integration. And in this step, we actually integrate with the existing lifecycle. Usually, after you push your code to GitHub, you have a process called code review, where you review what you actually wrote with either a colleague or your team leader. And this is really a best practice, and most organizations do that. What we want to make sure is that as part of the code review process, we also go over vulnerabilities if there are. So that colleague or that team leader should be aware that there is a place in GitHub as they do the code review to see whether the developer has any vulnerabilities in the code. If they do have vulnerabilities in the code, they need to fix that as part of the code review process, just as they would fix any functional bug that they would have, right? It's really a matter of understanding the process, the current process that your organization or development organization has, and really adapt the security aspects to that. The second thing that we have, or the third thing really, is the build step. The build step is where you actually push your code, whether it's Jenkins, Travis CI, TeamCity, Circle CI, or GitLab CI, any other CI/CD tool that you use. And usually the build is done automatically, but you also have some functional tests, right? Whether if it's a nightly build that you do in Jenkins, let's say, you make sure that it has automated tests and that there are no functional bugs. This is a great point to put security as well. So as a post build in Jenkins, let's say, you also look for known open source vulnerabilities. And this is something that WhiteSource Jenkins extension allows you to do. So, and then you can fail the build, just as if you would fail the build for functional bugs, and the developers would wake up in the morning and see what functional bugs they have and fix it. We fail builds for security issues. And this is a very important thing to mention, that we have the right actionable tools for developers as they actually write the code. So the focus here is not only about being secure, right? It's also about being efficient. We allow you to develop better software and to do it faster without compromising either on the security aspect or on the agility. So it doesn't mean that we're doing it, it doesn't mean that your organization will be slower It basically means that we will adapt to existing workflows that you already have in the organization and basically put the security aspect and highlight it. So for basically any team in the organization, we have the right tools that they need. We already discussed the developers, and we sort of discussed the other ones as well. But it's really important to understand that if you are the manager, you have the right tools to track it, right? It doesn't really. It's not only that the developer would fix the issues, it's also that you as the manager will have the visibility to see how many vulnerabilities were fixed, how much time did it take us to actually upgrade to the latest version, what was the process of the code review, how many builds in Jenkins failed because of security vulnerabilities. So we give both the managers and the security teams this visibility. They can run reports, they can get notifications for every time the build fails due to security issues. And same goes for legal and DevOps. So it's really not about having, just a simple solution that will fit everyone. We have, regardless really of what technology you use, like I mentioned, like I think 5 different CI/CD tools, 3 different repository management. So really for any existing tool that you use, we plug in there and we make sure that you have security aspects covered. We basically offer that one-stop shop for all open source, regardless of your environment. Or we didn't discuss languages, but development languages can really affect security issues. Some development languages have more security issues than others, and we basically cover all of them for the different personas within the organization. The second thing is really prioritization. I spoke about like thousands of open source components, right? For an average medium-sized company, this means more than hundred or thousands of open source vulnerabilities. So if you get that Excel report with thousands of vulnerabilities, you really have almost nothing to do with it. And prioritization is the key here. And we help you to focus on what really matters and guarantee that you have no issues and no false positives, and that you can really prioritize vulnerabilities based on your impact, not on just an average, go per severity, but on your specific organization impact. And the next thing is really the enterprise level, both support and the enterprise needs. So we don't only alert on you on actual issues, we also help you to fix it by, for example, having automated pull requests in GitHub or Bitbucket. So some of the case studies that I would like to show is really based on our own customer base. We scanned when we implemented WhiteSource, and we scanned 3 months after that. And we also asked the customer 3 months after implementation, what do you think? So first of all, in scanning, we actually found that the number of vulnerabilities was reduced by 90% within only 5 weeks of implementing WhiteSource. And this is really an amazing stat. In addition to that, the timeline of actually approving a component went down from 6 weeks to 3 days, right? The time that you approve an open source component. Unapproved licenses were really stopped and cold. Really over 80% of the C-level executives in the organizations really reduced, their blood pressure, their daily stress, and most importantly, everyone sleeps well because they know that you're secure in terms of the open source component. So now what I would like to do is really start with a demo, but before that, I don't know if we have any questions that we want to answer maybe now, or maybe we can jump to the demo.
Shri, let's take some questions. Guys, do we have questions from you till now? What we have discussed, please unmute yourself and ask Shri.
Okay.
Or you can chat. You can put your question in chat window also. We just wanted to know what kind of open source you guys are using, and if you are using tools like Black Duck or some more products which are already there in the market. So any kind of query, how you can do it yourself, or any upcoming thing. If you have any questions, please put it in chat. So while you think about question, maybe we'll start the demo. Shri, you go ahead with the.
Sure. So I'll start the demo. Let's see if you can see my screen. Okay. So let's start with the basics, right? Let's go to the WhiteSource home. So what you can see here is, first of all, this is the WhiteSource interface. And now what I'm looking at is I'm looking at the open source risk report. And this risk report actually tells me what are the risks within my organization. This is the home. So we have the full view of the organizational alert. And for library alerts, the most important stuff are here. So one of the things that usually more for managers or for development team leaders that they would like to see is how well am I tracking open source in the organization? So how many, we discussed the fact that new open source versions should always be patched, right? We also always want to be to have the latest version of that open source component. And here, as an example, I have more than 150 new versions of open source components that I'm using, right? Most of them, as you can see, are Debian based, and we can see that we have new versions available. So this is a very important aspect to know that there is a new version, 8.32, let's say, that is available for that Debian package that I'm using. And if I actually click on that Debian package, I can see what's the license, right? What's the language? I can see some more information, and I can also see the library vulnerabilities, right? What vulnerabilities are there? So this is a very important information that I can see in terms of my library. Now what we can do is we can actually pick another one, let's say this Roboto project, and we can see that we have 20 new versions, and that we have, in terms of security, we have per vulnerability alert and per library alert. This is really up to you how you want to see the alert. Let's click on one of them. What we can see here is that we have many security vulnerabilities. One of the things that I can actually see is that I mark security vulnerabilities, and I can see the how many security vulnerabilities I have in each actual package. And another thing that I can actually see here is the shields. And the shields represent what we call WhiteSource prioritize. This is the way to actually prioritize vulnerabilities. And if we actually click on that open source component, what we can actually see is for that vulnerability ID, whether it's effective or not. Does it actually affect my proprietary code or not? So think about the fact that in every open source component that you take, you have like thousands of lines or thousands of methods in the open source. You don't actually use all those methods in your proprietary code. You may use only 1 or 2 or 3 methods. If there are vulnerabilities in code, open source code that you're not actually using, it means that they are not effective. Even if there is an exploit or a vulnerability, it will not affect you. So the red shield that we saw means that this vulnerability actually affects my existing organization based on the scan. And this, of course, will be different for each organization, right? For some organizations, this package can be green. For some organizations, it can be red. It's really up to your existing organization. What I can actually see here in terms of the prioritization is I can see the actual trace, right? I can see the actual vulnerable line of code. And really, is it direct reference or indirect reference in this example? The second thing that I wanted to show you is the risk report. The risk report is, again, sort of a high-level view of everything that is related to open source components within the organization. So we can see the security aspect. The vulnerability score is high, which basically means I'm in a very high risk right now. I have more than 300 libraries where I don't have any known vulnerabilities, but I have 81 libraries that are actually vulnerable, and 55 of them are outdated, which means I really need to upgrade the version. We have the severity distribution, so we can see that most vulnerabilities are actually high, and the aging security vulnerabilities, meaning that 81 vulnerabilities here are there for over 90 days, and this is really not a good sign. We can also see the quality score, right? So we can see that I have outdated libraries, I have some up-to-date libraries, and I have libraries in the organization with multiple versions, which is always not a good sign. In addition to that, I can see that I have sort of a general overview per product. So let's say the product is a beta product. I have the actual names of the managers of that product. I have the total libraries, and then I can see that I have no risky licenses based on my organizational policy, and I can see that I have 21 security vulnerabilities. So this is really good as a high-level view of the open source. Another thing that I can see is the full list of vulnerabilities that I have here. You can see the top 6. So basically, this is the only thing that the developer needs to see. He needs to see upgrade to version X. What version should I upgrade to in order to eliminate the vulnerability? And we have also the project, the latest version, and some additional information regarding licenses. So this is really good in terms of seeing like a high-level view of the vulnerabilities. And I also see that we do have some questions. So I think this would be a good time to actually answer them. So the first question that we have is this solution identify the vulnerabilities only from open source? So this is actually a really good question. WhiteSource is an open source management tool. It's a software composition analysis tool, and with that, our expertise is definitely the open source component. So yes, vulnerabilities only from open source. And the second question is, will it support to scan the projects for Docker images or binary scanning? So yes, definitely. We have a lot of customers that actually scan Docker containers or Docker images. We integrate with various image registries, like for example, if you store your images in Google Container Registry, in ACR, Azure Container Registry, and I actually have some specific projects that are Dockers. So you can see this is Docker, and we have a native integration with Kubernetes to manage open source. So again, this is really a very good idea to mention that, and to mention the actual open source components and vulnerable components in Docker images. We scan both the base image, right, the base layer, the from like Ubuntu, Debian, etc. But we also scan the application layer, and we highlight vulnerabilities and licenses in both. Also, we'll find out the issues from the licensing terms. So yes, what you can see here, let's say, is the actual licenses, right? You can see that we have, so in this example, it's an LGPL license. We have a score both for the copyright and for the patent. And you can always see here that we have some risky licenses. What we call risky licenses are, for example, GPL, LGPL, etc. Another thing that I can do within the system is policies. So in this example, I can actually add a policy to, for example, reject a license of type GPL, since I think this is a very risky license for me. And I can just click a group of licenses, let's say all the GPL stuff. Once I click OK, I can click reject. I just need to provide a name. So let's say reject GPL by license group. And I click on add. Once I click on save, this rule will actually be applied. So this means that I will have a request or a task to approve anything that is GPL related, any component that has GPL license. Additional questions. For some of the CVEs, we are able to find the patches and we don't need to upgrade the open source software. In that case, how does WhiteSource detect whether a patch is applied or not? So the way that WhiteSource does the scanning in general is we have a scanning agent, right? So what we do is every time that you build, let's say, you run WhiteSource as a post-build step. So if you already patched something, let's say you upgraded to a later version, you changed something, you remove that component. In the next scan, WhiteSource will know that and will, of course, we will not highlight that vulnerability. You also have a special report for that. You can see the alerts report. And what I can actually see here is I can see all the security alerts, and I can see those over time, and I can also ignore specific vulnerabilities. So even if I didn't do the rescan, if I didn't scan again, I can say, for example, this high severity vulnerability, I can ignore it, it's no longer relevant. And I can also set some sort of a comment, like patched manually or something like that. And then anyone within the organization would know that I actually patched this specific component. Okay. So also, please show the demo how you find open source risk while developing itself. So this is a very good question. I don't think we will have time for it today, but definitely I encourage you. We have some videos online, and maybe we can send you later some demos about how we do the developer tools and show you some demos. We do have IDE integration and repository integration, and also the browser integration. So definitely, we would love to give you a demo for that. Okay, we are using Black Duck tool, looking at same as this tool only. I want to have a kind of IDE plugin to detect risks at the developer level and at the time of development. So definitely WhiteSource is a very good solution for that. We have the IDE integration that allows you to see the vulnerabilities and highlight vulnerabilities to the developers as they actually write the code. The second question, or another question that we have, is how frequently your knowledge base will be updated. And the answer for that is we have our own research team that actually finds new vulnerabilities, whether if they are publicly announced, or we sometimes also find vulnerabilities ourselves that are not listed publicly. And this is updated on an ongoing basis. I think that now the time is like every 5 or 6 hours. And this is really important. Like the frequency of updates is really important because new open source components are being discovered and published every day. So this is really a very important aspect. Another question is, can we create custom licensing policies? So I'm not sure what you mean by custom, but definitely you can add a policy and say either what I chose before was license group, but another you have all kinds of options. So you can just have a globe pattern on the resource name. So let's say you have some sort of like high charts, okay, like a high chart. You know that you want to always reject something if it has high charts in it. So this is another option for policy, by library age, by severity, by securities. So everything is here and it's very customizable. Okay, another question is, do we support on-premise or SaaS versions? So yes, this is what I'm showing currently is our SaaS version. 95 to 98% of our customers are actually using the SaaS version. We do have an on-premise solution as well. So if it's relevant, definitely we would be able to provide more details. I think this is it for the questions. And we're sort of done with the demo. So let me go back to the slide deck. And let me know if you can actually see my screen. Okay. And so I think we actually answered all the questions. We still have like 2 or 3 minutes for questions. So if you have additional questions, definitely feel free to post them here. And that's basically it from my end. Ankur, do you want to take it or?
Yeah. So, guys, if you have further questions, you can ask my team. And as we know, open source have become part of our life, our code base. We just need to make sure that we are using the right version of it. And we have solutions like WhiteSource, Black Duck, and other platform which can help you to use open source while complying all the licensing model and making sure it is we are not using some vulnerable component. Yes, Vijay, we will be able to get you a trial lessons, and I will make sure we give you demo about ID integration as well. And we will be sharing you the recording of this video. And if you want to have a demo for your company, we will arrange that so you can find out if you want to go ahead for proof of concept or not. We are much faster compared to Black Duck, and our database, especially for vulnerability, is much better. That's what we came to know from our customers. There are many people who are moving from Black Duck to WhiteSource. So thank you so much, all of you, to attend this webinar. I hope it was useful. Thank you, Shri and Eddie, for arranging this such a nice presentation. And we will send you some more offline questions if we get it. We will share with you, and we hope we will get in touch with all of our attendees about their feedback. So thank you so much. Thank you, Eddie. Thank you for joining the call.
Thank you. Bye-bye.